Continuing on with my history or story of the history of the atom, the next major person is Dalton. John Dalton, as you can see, you should by now you should have printed out this handout, or you're just using regular paper to write down these notes. John Dalton lived about the same time as the other people I had talked about before. And what he did was, besides doing his own experimentation, he kind of took a look at everybody else's experimentations, and he basically brought them all together into one kind into a theory about the matter in the world, and we call Dalton's atomic theory. There are four parts. We'll get to what's going on before his theory. Well, it's not really before his theory. It's people have by this time scientists have started to actually do experiments, i.e., the scientific method, write things down. And what they found was that they could take these base units or base particles and bring them together to form something else. And every single time they did it, they got the same thing. Or they took something else and broke them up, and you could break it up into these base units. And they started to have names for these things and explain the characteristics. So that's what's going on around the time that Dalton formulates his atomic theory. Why is it important? We'll get to in a few minutes. His theory has four principles or parts. That's why I put four different locations here. Okay, and I'm going to explain it to you, and then I'm going to give you what the actual words that most people use. The first one, what he said was, oh, before we do this, let me give you the definition of a atom. An atom is the smallest particle of matter that retains its own properties. It's the smallest piece of matter, if you like, and the big thing is it still retains its own characteristics and properties. Okay, so Dalton's atomic theory. The first part, he said, is that atoms are indivisible, meaning you can't break them up. So that's his first one, and that's kind of the way you say it. Atoms are indivisible. The second one he said was, he basically said a carbon atom is a carbon atom. So in essence, no matter anywhere in the world you go, a carbon atom is the same exact thing, including mass. Okay, and that's how what people say. Atoms of the same element are the same, including mass. Atoms of the same element are the same, including mass. And I'll repeat it once more. Atoms of the same element are the same, including mass. The next one, he said, well, if I have a carbon atom and I have an oxygen atom, a carbon atom can never be an oxygen atom, and an oxygen atom can never be a carbon atom. They're separate entities. And the way people explain that is they say atoms of different elements are different. Atoms of different elements are different, including mass. So atoms of different elements are different, including mass. That's the third one. And the fourth one is combinations of atoms. In essence, when you take atoms and you bring them together to create new things that we call compounds, they always come together in a fixed whole number ratio. Fixed whole number ratio. So the way people say that is combinations of atoms are put together in a fixed whole number ratio. Which should make sense, because if your first principle or rule says you can't break them up, so they must all come together in fixed whole number ratios, because if they're not whole number, then you have partial atoms, and that's not possible by Dalton. So that's what he believed. In essence, what he said was, if you want to learn or understand matter, in essence, everything in the world or universe, what you want to call it, you're talking about atoms. Atoms are king. And unlike before, where maybe the tree nymph or the god of fire wanted to change one substance into another substance, that's not actually what happens. What's going on is that there are these base units called atoms, and they're rearranging themselves. Okay. And this is such a basic understanding for us a couple hundred years later that we don't even, you're most likely going, yeah, well, yeah, I understood, I know that, why are we talking about it? Well, it was a big thing in that day, and that is the basis of all other theories. After this point, it is just correct to say that everything is made up of atoms. Okay. Next one is we don't live in that time anymore. We live a couple hundred years later. How do you do? So, updated the version of Dalton's atomic theory. So, number one, atoms are indivisible. That's not correct, because we know we have subatomic particles, electrons, protons, and neutrons, which we'll talk about in subsequent videos. So that's not correct. Second one is atoms of the same element are always the same, including mass. That's not true either, because that's what an isotope is. An element can or does have more than one isotope. An isotope is an atom of an element that has different masses. Okay, isotopes are atoms of the same element that have different masses. And just so you know, the reason why they have different masses is not because of the number of electrons or protons, it's because of the number of neutrons. And we'll get to what a neutron is later. Third one, atoms of different elements are always different. Now, in my class, because I don't really deal with nuclear chemistry or nuclear reactions, this is true. You can never make a carbon atom into a chlorine atom. That's not possible. Okay. Now, if you want to, you're going to, in very small parentheses, you can say it's not true in a nuclear reaction. The problem is, in a nuclear reaction, you can't just say, hey, I want to make this carbon atom into a chlorine atom. It doesn't work that way. In nuclear reactions, either breaking up or bringing together, there's only certain ways or certain types of elements become other elements. Okay, but for our class, that third one holds true. Atoms of elements cannot become some other element. And the fourth one is always true. Actually, the fourth one is another way of saying a compound. Because remember, compounds are two or more elements chemically combined in a fixed mass ratio. Well, if every atom of the same type has a specific mass, and they're by Dalton coming together in a fixed whole number ratio. Well, that fixed whole number ratio is also a fixed mass ratio. So this is another way of saying what a compound is. Okay, now at Dalton's time, when he came up with his atomic theory, what came from it and came about at the same basic time are three laws. And the first one is the law of conservation of mass. Well, as you know, the law of conservation of mass says that mass is conserved. Well, if you look at it with respect to Dalton, which Dalton says, if you want to know about mass of matter, it's all about atoms. So if it's the mass is conserved, then the total number of atoms are conserved. But it's not only that, it's the total number of each type of atom is also conserved. So with Dalton, he expands, or you can think, using Dalton's theory, you can see that the law of conservation of mass expands to basically atom conservation. The next two, law of definite proportion and law of multiple proportion, I will deal with in a different slide. Basically, law of definite proportion says that since both of these laws come from the Dalton's atomic theory, definite proportion says when you have a compound, these materials always come in elements, or atoms always come in a fixed ratio, fixed mass ratio. And it stays constant as long as you stay with the same substance. Therefore, you can figure out how much of each of the things that make up the compound you need, because they always come in the same ratio. And then the law of multiple proportion is a little bit more complicated in their explanation. But basically, what it's talking about is that when atoms combine, they always combine in whole number ratios. Both the law of definite proportion and the law of multiple proportion, even though it's using like counting of atoms, both of those laws usually are dealing with massing. So when you see the law of definite proportion, the law of multiple proportion, you should be thinking massing material, not counting material. Okay, so I'll stop there, and I'll have another video to talk about those two particular laws. So to recap, in general, what Dalton said was, if you want to know about matter or things in your environment, it's all about these things called atoms. Atoms are king. Thank you.